All right, so on to section 8.5. This one has a little bit more meat to it than 8.4 did. So we'll go ahead and move through as quickly as we can. If you don't get through it today, you can watch it tomorrow. More than likely, I will not be back tomorrow. Apparently what I have is very contagious, and even though I look like I'm fine, which I really am, I can't be around you because then you might get it and it sucks and you don't want to have it. So, section 8.5. Theorems involving proportions. Okay? I'll write the theorem down, then we'll talk about them like we usually do. This is the first theorem. Is theorem 65. If a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. Fancy term, side splitter theorem. Okay. For example, let's take a triangle. A, B, C, and draw in X, Y, so that it is parallel to BC. Now, I'm at an odd angle, so probably doesn't actually look parallel, but you get the idea, okay? Obviously, these are not congruent by the picture, okay? They are not supposed to be congruent because this is not the midline. Remember, the midline theorem said that if we took the midpoints of the sides of the triangle and we connected them, that it was half of the length of the side that it was parallel to. This is not the midline because these are not necessarily the midpoints. X and Y are not midpoints. However, X and Y do make a proportionality here, and here is why it's actually proportional. Remember, theorems are mathematical statements that can be proven. Well, what do you know about triangle AXY and ABC? How are they related to each other? Are they congruent? They're going to look congruent. Obviously, AXY is smaller than ABC. They're not congruent. They are similar. How do I know they're similar? You don't know anything about the sides. Well, no, but I do know about the angles. Watch this. Angle A, congruent to itself. Agree? Agree. Reflexive property. These two lines are parallel. So that means, remember this theorem? What kind of angles are these? These are called corresponding angles, which means that angle AXY is congruent to angle ABC. Right? Right? Can you do the same thing over here? Sure can. So this is congruent to this. So that means that triangle AXY and ABC have congruent angles. 3 congruent angles is angle, 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 which means that the two triangles are similar. So because of that, we can prove that AX over AB is proportional to AY over AC. Okay? That's because they're similar. However, this theorem lets you go one step further, and you don't actually have to do AX over the whole thing, AB. You can do the little sections. AX over XB is proportional to AY over YC. So this theorem actually tells us that AX over XB is equal to AY over over YC. Okay? That's all the theorem is, side splitter theorem. Now you're going to use this mostly for algebraic types of problems, but you might actually end up using it for some geometric proofs as well, okay? This is not heavy on proofs in this section, but you may find that you have a proof or two that has this in there, okay? Side splitter theorem. That is theorem 65. We have 2 more theorems to go in this section. See that? And I lost my pen. There it is. Okay, theorem 66. Very similar to the side splitter theorem, just few short little differences. I don't actually have to have triangles in theorem 66. So theorem 66 says that if 3 or more parallel lines are intersected by 2 transversals, where am I? Oh. Then the parallel lines divide the transversal proportionally. No fancy name for this theorem, just know and understand it. This is one that you will more than likely not use in geometric proofs. For me, you will use these to do actual math problems, algebraic problem solving for missing side lengths. So here's what it does. First I have to have what? What's the theorem say? What's the very first thing I have to say? 3 or more parallel lines. So here's one parallel line. Luckily for me, this is lined paper. And still, make them straight. Okay, so 3 parallel lines intersected by 2 transversals. It actually can be 2 or more, but 2 transversals is what I'm going to compare. So, transversal 1, transversal 2. Okay, goes by the same idea that we just talked about with the side splitter theorem. The reason it works is because of the proportionality that would be created should these 2 lines intersect and make another triangle. We would get proportionality because of the triangles. And this goes x, I'm sorry, forget that x. I don't really want to do what I have here. A, C, E, B, D, and F. Okay? So, if 3 or more parallel lines are intersected by 2 transversals, then the parallel lines divide the transversals proportionally. Again, in math, you know how we are. We state what we mean, and that's what the theorem actually is doing, exactly, explicitly what it means. So what does this mean? Well, it means that then AC over CE, AC over CE is equal to what? BD over DF. That's all it means. Okay? Also means that, well, never mind, I don't want to go that far. So the pieces are equal here. Okay? So AC over CE is equal to BD over DF. DF over BD is equal to CE over AC. Okay? The order matters, but just like we talked about before, either one of these can be the means, either one of these can be the extremes. So you can rearrange them just so long as AC and DF stay together when you're cross multiplying. Okay? So instead of AC over DF, we could have DF over AC. That would, I'm sorry, instead of AC over CE, we could have CE over AC. Wouldn't make any difference. So just like that theorem we talked about a few days ago, same idea here. So it doesn't matter as far as that goes, but you do need to keep the order. You could go, let's see, make sure I do it right, since now I'm on tape. AC over CE, so that means that as long as AC times DF is equal to CE times BD. So how are some other ways I could write this? Well, I can put DF on the bottom here and BD on the bottom. So AC over BD, if AC over BD, then that means that CE is over DF, okay? So just trying to keep that proportionality, keep that order in line, you're going to get what you need. Lots of different ways you can write that one. That is Theorem 66. All right. Moving right along to Theorem 67. Get myself another piece of paper. Okay. Theorem 67. If a ray bisects an angle, it divides the opposite side into segments that are proportional. To the adjacent sides. This is called the angle bisector theorem. All right. This one kind of is disproving what some of you all thought in the beginning of the year. So let's say I have a triangle. And I bisect this angle. Okay? So, I know, sorry. Didn't draw it to scale. Don't have an eraser. Use your imagination. The two angles are congruent. Remember, we can never look at a picture and assume anything. Can talk about relative sizes. But assume nothing. I'm telling you, these are congruent. Okay? Now, at the beginning of the year, you all said that if we bisected the angle, we must bisect the opposite side. And I said, no way, no how. That's not the way that it works. This is the theorem that shows what actually does happen. So, for example, let's see, what do I want to call these guys? I guess it doesn't matter. X, Y, and Z. And I'm going to tell you that XY is 8. Let's put another letter in there. W. XW is 4. YZ is 10. And I want to solve for X. I guess I should have used some other variables. Okay, so I want to solve here. So my angle bisector theorem says that I can set up proportions. If the ray is bisecting the angle, it divides the opposite side so that the segments that are created are proportional to the adjacent sides. Now, what does adjacent mean? Remember, we talked about this before. Adjacent is your next door neighbor. It's actually the one that touches you. So it is the one that is right next to you. So the adjacent side would be, for XW, the adjacent side would be XY. They share the same X. For WZ, the adjacent side would be ZY. They share the same Z. Okay? So, for example, on this one, we would write a proportion, and the proportion we would write would be 4 over 8 equals, well, if I started on the bottom and did 4 over 8, should I do 10 over X or X over 10? How should I make that proportion, and what would make the most sense? 4 over 8 equals what? 4 over 8 should equal X over 10. Well, that's just simple cross product, means extremes product theorem. Just cross multiply and solve the bad boy. So 4 times 10 is 40, and 8 times X is 8X. Divide by 8, and 5 is equal to X. Voila, the angle bisector theorem. And there you have it. That is section 8.5. You now have everything you need to learn chapter 8. You've been presented with all the material, so you will spend, I don't know how much time this has taken up. If we've taken up all the time for today, then tomorrow you will spend your time reviewing and doing the worksheets that I left for today. If you have not finished, this didn't take up all the time for today, you can start working on those worksheets now. You will stick with the schedule. Whatever is on the schedule for tomorrow will be due the same time that it will be due regularly. So if I don't remember, I don't have it in front of me, if I had scheduled the test to be on Tuesday, the test will still be on Tuesday, probably be more like a quiz, just like the last one. So that's it, guys. Hope you guys have a great weekend. Have a great afternoon, and stay warm in the snow. See y'all Tuesday.